this is always an area of concern because you don't have data just to secure it. You actually want to use it. So the applications are going to have access. Users that are have credentials to use those applications are going to have access. What do we have to worry about when we're using microsharding for this particular area of the flow?
Greetings, everyone, and welcome to today's webinar, Beyond Encryption, How to Securely Implement and Audit Microshard Technology. This webinar will cover best practices for secure deployment of Microshard technology and how to assess the security control as an auditor. From the storage locations to the Microshard engine, and finally the application security layer, this webinar will provide a comprehensive overview of how to mitigate breach risks and reduce compliance burden. We'll also be discussing why IT professionals are implementing Microshard technology and how auditors are evaluating the same, which provides a critical failsafe for modern security infrastructure. Our speakers today are Zack Link, Senior Security Engineer with ShardSecure, joined by our guest speaker and moderator, Robert Clyde, ShardSecure Advisor, ISACA board member, and former CTO of Symantec. Rob?
Thank you. Well, it's a pleasure to have the opportunity to talk about this subject. I think for many of you, this is new, and understanding microsharding, what we might use it for, and why we might use it is probably new to most of you that are attending. I'm also guessing that you're wondering, how can I actually securely implement this? What are the considerations that go into play? What are things I don't need to worry about? What are things I do need to worry about? And why might I do this? So I'm going to moderate this session. I'll be interjecting with a few thoughts of my own, but especially I'm going to be asking questions of Zack, who is an expert in this area, and will take us through this subject and help us to understand these types of issues. If you do have questions, please feel free to use the Q&A aspect of Zoom and submit a question. I'll look for that and then ensure that we address that particular question. One last point, Robert did mention that I am on the board of directors for ISACA. Love ISACA. Hopefully we have some folks that are with ISACA that join, but obviously in this session, these are my opinions and not those of ISACA or any other companies that I might be affiliated with at this time. They're my own opinions as a longtime cybersecurity expert and somebody who's played in this market for many decades. With that, I'd like to start off with a question of Zack. So Zack, what exactly is microsharding? And maybe you could first tell us a little bit about why we might use it so that we get a little context as you go into what it is.
Thanks for the introduction, Rob. So my name is Zack Link. I'm a senior security engineer for ShardSecure. And going into Rob's question is why use Microshard technology in the first place? So there's really four main reasons. One is to reduce the data sensitivity. So microsharding is not going to prevent your data from being leaked or stolen, but the microsharded data is incomplete and unreadable in any single storage location. It just looks like random bytes. So it's totally unusable to an attacker or anyone else. In the event that your data is breached, it's not going to become a headline-grabbing event. Because of the reduced data sensitivity, it also has the potential to remove the data at rest from the scope in your audits, making everyone's job a little bit easier. The second reason is for defense in depth. Everywhere in cybersecurity, we use multiple security controls. So in the event that one control fails, other controls still provide a safeguard. We do this everywhere except for data at rest. Encryption is pretty much the only control for data at rest. And while the algorithms have gotten better, the keys have gotten longer, we still seem to be having breaches where encryption has failed us. And it's not the algorithms, it's the implementation, right? The third point is really decreased attack surface. So some of the largest breaches in the last couple of years have been from back-end access to cloud storage. In fact, there was one announced just yesterday, if you guys caught that, a large retailer lost 300,000 records. And they had a misconfigured an S3 bucket, and people were able to pull down that data. And this is one of the downsides to encryption, to server-side encryption, is that if you're authenticated, it's effectively like there's no encryption at all. So by microsharding your data, you reduce this attack surface. The fourth reason is really for increased privacy. So microsharding is one of the only controls that I can think of that actually separates your privileged account users from the underlying data at rest. Your admins can still, do backups and restores and whatever tasks they do, but they don't have the ability to read any of the sensitive data that they contain. The next question is, what is microsharding anyway, right? So it's a fairly new technology to secure your data at rest. And it basically uses a three-step process. So for the first step is to actually shred the data to reduce the data sensitivity. So we have a 400 byte file here, and it gets compressed into a 320 byte file. And then that's where the shredding happens. So you can kind of imagine this just like a cross-cut paper shredder, where that 320 byte file is sharded into 4 byte microshards. So there's 80 of those, okay? The next step is to mix the data to eliminate the data
Zach,
value.
can I ask you a question? Why 4 bytes?
Sure.
What is there something special about that?
Yeah, and I'll dig into that a lot more, but the main point is that the microshard size has to be smaller than the data that you're trying to protect so that the data is incomplete when it's mixed up, if that makes sense. So in this case, so now we're going to mix up the data. So we create a number of microshard containers, and you can see that, say, for example, this was a file full of credit card numbers, each credit card number being 16 bytes. With 4 byte microshards, you can see that credit card would be broken up into 4 different pieces, box 1, 2, 3, and 4. Now, box 2 ends up in this microshard container, where boxes 1, 3, and 4 end up in other microshard containers. So there's no way, if this file is breached, that you could reconstruct that credit card number. Only part of it would sit in that file. Now, in addition, you'll see a red box here, and that is actually poison data. So you also have the ability to add some random microshards, random data microshards into that data to make it even harder to reassemble that file. The microshard containers are then stored at rest, and you can see that there's no longer any file header information, so you don't know what type of file it is. There's no extensions to give you an indication of that. There's no file names. And each one of these microshard containers doesn't have any location data about the other microshard containers from that file. So there's no way to find the location of those other microshard containers. So what this means is that anyone that has back-end access to that file system can no longer, read any sort of meaningful data from that. And that includes your privileged account users like IT admins or cloud admins, your cloud providers, any third parties that have access to your storage locations. They cannot see that underlying data.
So Zach, this is fairly significant, if I'm understanding correctly. Just before you show that sample data, not only can't you read anything, but we're also not getting enough of the data in any single location, correct?
Correct. That data is incomplete. So if you exposed, a whole bucket and someone downloaded that data, it would still only have a fraction of each file in there. In addition, what is in there would be mixed up, but it would still only be a fraction of data. So for example, when we talked about that credit card that was broken up into 4 pieces, the 4 pieces of that credit card are going to be in totally different storage locations.
Interesting. So from the perspective of regulatory compliance or from the scope of IT audit, as you kind of mentioned earlier, then that means those storage locations technically don't actually have any sensitive data, which
That is
should mean
correct.
they're out of scope.
That is absolutely correct. So if one of those storage locations was exposed, data was downloaded, you could validate that there was only pieces and fragments of information. So there wouldn't be a whole credit card in there or a whole social security number in there. There might be small fragments of that, which at that point is meaningless.
Yeah, I think that's very significant and really could be a game changer because it really makes a difference in what you have to do from regulatory compliance standpoint, what actually you have to worry about from an IT audit standpoint. I can't wait till we get further on into this and understand better what concerns you still have in those storage areas.
Absolutely, absolutely. So the last part of this is just to show you what some sample data looks like. This is actually a healthcare record that includes things like name, address, date of birth, social security number of a single user. And it was split into 4 different buckets. I've labeled them here by the different clouds that they were sitting in. And you can see that this data is unintelligible. If an attacker had, even if they had all 4 of those buckets, they would still not be able to make any sense of this data at all. And mathematically, this is actually harder to reassemble than AES 256. So there's really just not enough compute and time left in the world to try to brute force this. So, first we did, the first step was to shred it. The second step was to mix it. And the third step is to distribute that data to the storage locations. So we have that original file, and it was broken up. Broken up into 4 different Microshard containers. And those Microshard containers are now streamed out in parallel to all your storage locations. And you can do this as a single cloud, a multi-cloud, or even like a hybrid cloud where some of the storage is either in your data center or in a cloud adjacent data center. So you can really mix and match this however you want. So you can imagine that if we talk about that original credit card number, you would have 1/4 of that credit card number in this cloud, 1/4 in this one, 1/4 in the cloud provider 2, and then 1/4 in the data center. It would be a pretty amazing breach where that one single credit card number could be reassembled in any way, shape, or form.
And if I understand correctly, in each of those locations actually doesn't contain any sensitive data.
That is 100% correct, right? So data is totally incomplete and unreadable in any single storage location. All right, so how does microsharding fit into your environment? So it really sits kind of here in the center. You would have a Microshard engine, which is basically just a cluster of nodes. And then you'd have your application layer on the left-hand side here. So this would include your app servers, your database servers, whatever device you have that needs to store sensitive data. And they would connect to the Microshard engine just using your standard protocols, things like iSCSI, SMB, NFS, or even APIs like an S3 API or something like that, where the Microshard engine could be treated as an S3 bucket, for example. So you can kind of think of the Microshard engine as sort of a secure NAS front end to your back end storage. And then here's all your storage locations. And so the Microshard engine is responsible for shredding, mixing, and distributing that data and putting it to rest in those locations. And then when your app server or database server needs to read that file again, the Microshard engine does the exact reverse and reassembles all that data and streams it back to your server in real time. So this is a real time on the fly solution.
So Zach, I think it would be useful now to kind of dig into a little bit of how do you securely implement? What are some of the considerations? What are considerations that an IT auditor might be looking at as well relative to this? And I think it would be helpful to go through, if you look at this flow, you've got 3 separate areas. If we were to move from right to left, starting with the storage locations, and then talk about the Microshard engine, and then talk about application servers and databases. And let's discuss for each of these what those considerations might be. Starting with the storage location seems like the logical area for me, because you might have terabytes or petabytes or maybe even exabytes of data that you're having to deal with here in the storage locations. And I think you've already said one of the big implications is there's no single storage location actually contains sensitive information. It's a huge difference with the use of the Microshard engine approach versus any other. And you might even contrast a little bit some aspects relative to encryption as well for us with that.
Yeah, and absolutely, that's correct. Let me actually talk a little bit of terminology first before we drill into that, just to get everyone up to speed. So a shard is a fragment of data, and everyone on the call is probably familiar with the word shard in relation to databases. And at risk of oversimplifying it, sharding of databases is basically just splitting a database, horizontally, and then taking those pieces and putting them out on different database servers or clusters so that you can scale out horizontally. The data is still intact on each one of those database servers. It's purely for scale, right? Now, Microshard is a very, very tiny fragment of data. And the idea there is to make the fragment so small that it no longer contain sensitive information. So while the words shard and microshard are similar, and the concept is sort of similar, they really have totally different goals and totally different results. Whereas sharding a database is really all about performance and scaling horizontally. And microsharding your data is really all about securing and privatizing your data. So do not get confused with these terms. They're very different things, even though they sound similar. The next term we're going to talk about is shard size, and that's something, Rob, you were asking about earlier, and that's the size of a single microshard fragment. So we'll discuss that more later. The shard file system is where those shard containers are stored, and I'll probably just be referring to those as storage locations throughout the rest of this webinar. So if I say storage location, think the shard file system. And then the next two ones are interesting. The pointer database is a tokenized database that has the instructions to reassemble a file. The host map are the tokens, and they actually point to where the data is stored. So that means the pointer database knows how to reassemble a file, but doesn't know where the data lives. And the host map knows where the data lives and doesn't know how to reassemble it. So you really need both of those things, the pointer database and the host map, to actually reassemble a file. Functionally, those two together work a lot like an encryption key. They perform the same function as an encryption key in that they, shred and reassemble data. But the pointer database and the host map file has a lot of advantages over an encryption key, right? So encryption keys have to be used where the encryption is done. So for example, if you're using client-side encryption, the encryption key has to be out on your application servers or your database server to actually decrypt that data. Now, if you go ahead and Google, GitHub secret scanner, you're going to find hundreds of tools out there that will just go scan GitHub repositories looking for credentials and encryption keys and certificates and things like that. There's been a huge amount of leaks because your encryption key, if you're using client-side encryption, has to be embedded in code, embedded on your servers, wherever that stuff happens. So one of the advantages of Microshard technology is that pointer database and host map file remain solely on the Microshard engine itself. They don't have to be shared anywhere else.
Great. Well, let's talk a little more about the storage locations and what the security implications are there. I think that would be really helpful, Zach.
Perfect. So when we get down to the storage locations, the first question people have is like, how many are enough and how many are too much? So, one of the pillars of Microshard technology is that the data is stored in a distributed fashion, right? So the data is incomplete everywhere. So obviously you need more than one storage location. I like to give it a rule of thumb of 4 as the absolute minimum. Technically, you could probably go 2, but that means that each location has 50% of the file data. And even though it's shredded, you'd really like to keep that down to a fraction of that. So if you go with 4, there's only 25% of the file in any single storage location, which is really nice. If you go up from 4, you kind of get diminishing returns. Even if you went up to 10 storage locations, you're talking about 10% of the file versus 25% of the file. It does get a little bit harder for attackers, but it's sort of diminishing returns. So as far as storage locations would go, I would recommend a minimum of 4 and probably a maximum of 10.
Great. So that's that seems like an important item for security people to take into account and IT auditors to ask.
Absolutely. Absolutely. So the next point is storage platforms. And by that, I mean like cloud providers, like how many different cloud providers do you want to use? And certainly you could have a secure deployment using a single cloud provider. That's definitely possible. You can also use hybrid clouds where some of it's, on-prem as well, or even multi-cloud. But the biggest part of that is, do you have any admins that have access to all the locations, right? If the answer to that is no, you're definitely more secure. You're not going to have one single compromise that would allow an attacker access to all the different storage locations. So clearly, getting 2 privileged accounts is a lot harder than getting 1 privileged account. So you can either go multiple.
That seems like a really key question to ask as well. Is do we have separation of duties with at least 2 cloud admins that don't have overlapping data storage areas?
Yes, absolutely. That definitely adds a huge layer of security to that.
If you could just kind of contrast that real quick, suppose I had a couple of different cloud admins without overlapping storage areas, and I was using encryption, say the native encryption of AWS or Azure or Google. What's going to be the difference there in terms of the attack surface and data sensitivity surface?
Yeah, so the great thing about that, first of all, is that Microshard technology is actually absolutely transparent to encryption. It can be used in conjunction with both client-side encryption and server-side encryption with no change to how you do anything, right? So it's absolutely transparent to implement both those controls. So that's really good, but it also gives you a failsafe. If you can, you can think of the microsharding as the backstop to the catcher of encryption. So you could use really simple server-side encryption, just the checkbox that your cloud provider allows, and then also Microshard that data as well, and you'd have something that is very, very resilient. As well as something that is very, very easy to use.
Great. So I understand I get defense in depth if I use both. Let's suppose I just use the server-side native encryption that the cloud provider has. And one of my cloud admins is broken into. What are they going to get? What are the bad guys going to get, the attackers?
So yeah, the default encryption in the cloud, I see a lot more companies using that, and it's really kind of scary because if you do not control your keys, if you don't issue your keys, revoke your keys, if you don't handle your keys, that should be a red flag. If your encryption is so easy that you can just hit a checkbox and never have to see anything encrypted and never have to deal with any keys, that's a red flag that implementation might not be very secure. So in the case of like server-side cloud encryption, if you have a privileged account, that data is treated as if it's not encrypted at all. You could go in, look in a storage bucket, download a file, and the cloud platform handles that and automatically decrypts it for you without you asking. In addition, you can manage your cloud through a browser. So think about this. You can go through the most complicated authentication with MFA and all those kind of things in your browser, and you're going to get an access token that says you are authenticated, you have these privileges. And that is stored in a browser cookie. And then if you access the cloud, it's going to say, oh, well, you have that cookie. So we're going to decrypt all this data for you that you have encrypted automatically for you in real time. So you went from a situation where you say, yes, I'm using encryption, my data is encrypted at rest, but the whole thing could be subverted by stealing a browser cookie.
Wow.
So
yes.
there's some flaws to the implementation.
Yep. Okay. I now see why you were recommending, at the very least, using microsharding. And if you're using both, you get that defense in depth. So it also seems like from a data sensitivity standpoint, I also have that issue too, because obviously all the data is there for, from a sensitive data perspective. I do have credit card numbers, for instance, or personal data stored in each of those storage locations. And even if it's encrypted, a single admin breach will result in the loss of data. Or I should say the leaking
Correct.
of data. Okay.
Yeah.
I've got it. All right, that's great. So you said earlier that microshard size in your example was 4. Does it always need to be 4, or are there options depending on what kind of data?
Yeah, so if you're auditing a Microshard deployment and they say 4 bytes, well then you could probably stop there with your questions. And the reason that is because like the smallest sensitive piece of data I can think of is a social security number, which is 9 digits. So my rule of thumb is that your microshard size has to be small enough to break up your smallest piece of data into 3 different chunks. That way, no single piece of data has a majority of it. Like say that you went with 8-byte microshard size for a social security number. Depending on how the byte boundaries lined up, you could have 8 digits of a social security number. An attacker would only have to guess either 10 digits at the end or 10 digits at the beginning, and they could get a social security number. So you really want to use smaller amounts. So 4 bytes really works for everything. Now, as far as other sizes, maybe you're in the healthcare industry and you have things like MRIs and X-rays and image type files, which can be a lot larger and don't have the same sensitivity as a clear text social security number. Then you can definitely use larger than 4-byte size. You might use 128 bytes or 256 bytes. But what I tell people is that if you're going to use more than 4 bytes microshard size, then you really need to look at the data that you're trying to protect and ensure that it's getting broken up into 3 pieces to ensure its safety.
So it would seem like one of the things security professionals and IT auditors should ask about microsharding is, can I choose the size of the data? And ideally, can I choose it based on what type of data it is?
Yes, absolutely. That's an important feature. Again, one of the 3 pillars of Microshard technology is the microshard size. So definitely something to be sensitive to.
Great.
One thing I missed on this was the principle of least privilege. Who should see your data? I talk to a lot of companies and we discuss their sensitive data. And that's usually one of the questions I ask is, well, who should see this data? And, for example, someone will say, oh, well, our HR department should see this data. And then I'll ask, who can see your data? And they'll say, oh, well, we've got our cloud admins. They have access. They can see that data. We also have some developers that work on that platform, and they have access. They can see that data as well. And, oh, by the way, we outsource some of our operations to a third-party company, and so they actually have access to that environment, can see that data. And what I say is that according to the principle of least privilege, if there is any difference in those two answers of who should see your data and who can see your data, then you've kind of failed the principle of least privilege. And so any extra people that can see that data is just extra risk, and it's usually needless. And using Microshard technology actually allows you to separate, make that data private to privileged accounts, which is really hard to do otherwise. So it closes that gap, really.
Zack, you've talked a lot about privileged accounts. I mean, why are we worrying so much about privileged accounts in terms of being a target of attack versus other accounts? Is there really that big of a difference in terms of what attackers target?
Certainly. If you look at trends in the industry, attackers want to get the most privileged access they can. You can look at how many attackers target AD and try to get domain admin creds. It really eases the rest of the attack because we tend to give administrators huge amounts of access, of essentially unfettered access through your environment. There's very, very few controls on privileged accounts. So it's kind of a master key to everything in your environment. So you have to control those really well. They're obviously, what attackers are trying to get.
So let's talk about those users, the admins, from a practical perspective. The admins, the cloud admins, do still need to manage those environments, the storage environments. Are there going to be, since they can't actually see the data anymore, are there really any restrictions on what they're able to do, though, from their primary job function, which is to administer those areas and make sure they're operational?
Yeah, so certainly they won't be able to see the data anymore, but they can still manage file systems. They can still do backups and restores and things like that. And in the case that maybe they do need to sometimes see the data, they can still be given an application account. So you can really separate those privileges. So instead of just giving them a carte blanche, you can see, all the data at rest, in its raw format. You can protect that data from them and force them to come in through an application account, which is probably where all your security is focused and where you have a lot more granularity of controls like RBAC and things like that that can really help control what they can see and do.
That makes sense. And I think you'd also have the necessary auditing of any access that the admins would be doing, going through that type of a method. They're going through the front door is one way to think about it, to get to the data instead of the back door.
Correct. All right. So moving on to the
so this seems like a really big area, and what would be my natural question, since I've added something new to my environment, which is the Microshard engine, what do I have to do to protect it?
Yeah, and that's a good question. So let's move on to this. Of course, there's, all the normal stuff you have to do, just best practices. So, hardening, vulnerability assessment, and patch management, of course. Now, one of the nice things about network access is end users are not going to be connected to the Microshard engine. Really, it's going to be your application servers, your database servers. So this can be buried pretty deep in your network and be, well controlled from a network standpoint. With very little access to it. So that adds a layer of security right there to your Microshard engine. And then as far as authentication goes, obviously you want to follow best practice and keep separate credentials for each application, rotate them periodically. And then I was having a conversation a couple of weeks ago, and this kind of came up, which was, well, which admin accounts, which user directory should I have my admin accounts of the Microshard engine itself? And I had to think about it for a minute. On one hand, you could put it in your AD, for example, right? You could have your AD admins or your Microshard engine admin just in AD. But if that's also the same credentials that they use for cloud access, if an attacker compromised those credentials, they would have access to both your cloud environment and your Microshard engine, which is probably not a good thing. So there could be a very good argument made for keeping separate credentials for your Microshard admin versus your cloud admin. And so that, maybe you set up a different Azure AD, or maybe you use a third-party identity service like Okta, or if you're deployed in AWS, you can spin up a Cognito. And that would actually keep your cloud admin credentials, even if it's the same person, different from your Microshard engine admin credentials, which would definitely add a layer of security. Now, the downside to this is, do these other user directories, are they integrated into your MFA? Are they integrated into all the rest of your security tools? Are they monitored? Do you have strong policy enforcement on them? So for every environment, they're going to have to really look at what their capabilities are, because if they don't have those capabilities in secondary directories, they're probably better off actually using, their AD or whatever they're using for their user directory for their Microshard admin as well. But if they do have those capabilities like MFA integration and prevention and monitoring of things, then they could definitely use a different directory and add a little bit more security there. So it's going to be really dependent on capabilities.
Okay, I get it. So you mentioned MFA a couple of times. Are you recommending that MFA be used? And if so, why? Is that extra step necessary?
I recommend MFA for anything. I recommend MFA for home users that are logging into their Gmail. MFA is not perfect, but there's certainly, bypasses for MFA. And earlier I mentioned, anything that has browser access, it's storing an access token as a cookie in your browser. So, that all being said, MFA is better than, a password, just single factor authentication. So I'm a big fan of MFA for everything, even with its, even though it's not a silver bullet.
Got it.
So the next point is the host map and pointer database. So these, as I mentioned earlier, these only have to reside on the Microshard, did I say Microsoft? The Microshard engine itself. They don't have to be shared out into application servers or anything like that. So it definitely makes less chance of those being leaked. They also have to be backed up, and the backup needs to be secure. So kind of moving into the backup disaster recovery point here, your host map file is very static. It only changes when you're adding or removing storage locations. So that you can just keep 2 copies of that in a secure location offline, and that's fine. The pointer database itself is actually really dynamic. Every time a file is created or deleted or edited, the pointer database is going to change. So that actually needs to be backed up on a very regular basis. Now, the other point is that the pointer database should be in sync with your storage location. So whatever sort of schedule you use for your storage locations backups, you should just use the same schedule for your pointer database. That way, if you ever do have to do a disaster recovery scenario, then everything is in sync, and it just makes it a lot easier for a very quick recovery. Honestly, recovery, since all you need is a host map and a pointer database, you can spin up a new server, put those 2 files on it, and you're back up and running. So disaster recovery is a very easy affair.
So from a security perspective, you had said earlier that you need both the host map and pointer database to be able to see the data in the files that are in the storage area. And it would seem that since the host map file is static and the backup for that can be stored offline, you should be able to end up in a situation where the backups of your data are very secure, because you're not backing up essentially the keys as well to get to the data. You need both files. Exactly.
Like if you actually did a backup of the Microshard engine itself, the host map file actually would not exist because it's only held in memory. So it would not even be in your backup. So if for some reason someone did get a hold of your backups, they would still not have all the information they would need to reassemble files.
Okay, got it. So you might put the host map file on, say, it's not very big, right? I could put it on like a USB key or something like that and securely store it.
Oh, certainly. Yeah, I mean, it's measured in maybe a K or 2K or something like that.
Got it. That's very helpful.
Perfect. So now I think we're going to get to the other stuff here. So application
So let's
layer.
talk about this last area, Zach. You know, this is always an area of concern because you don't have data just to secure it. You actually want to use it. So the applications are going to have access. Users that are have credentials to use those applications are going to have access. What do we have to worry about when we're using microsharding for this particular area of the flow?
Yeah, great question. This is kind of the this is the important layer, right? We reduce attack surface a lot, but the attack surface, this is what's left for the most part. So first, let me explain front end and back end access, because I've been using those terms a lot. And I was talking to someone a couple of months ago, and I was talking about front end and back end access, and the guy said to me, "There's no front end and back end in the cloud. It's all APIs, so everything is a door, side door, back door, front door. Like it's irrelevant at that point." And you know, he has a point, but the terms, the way I'm using them here is when I say front end, I'm really talking through your application. Whatever that application that's using the sensitive data normally is your front end access. The back end access would be through your cloud provider. So whether you're using AWS or Azure or a different cloud, you know, administrative access to that platform that can then grab storage would be a back-end access. Now, so if we look at how we secure those two things, right? Available controls for the front end, there's hundreds of security companies out there that will sell you products to protect the front end. And you're probably using multiple solutions for these, you know, different things, right? You might have CASB, WAF, IPS, UEBA, you know, any whole stack of tools there. And yet on the back end, we don't follow that because really the only solution we've ever really had is encryption. And there's both server side and client side. I touched on this a little bit earlier. And the server-side encryption is really kind of what I see everyone using now. It's so easy. You can get your cloud provider provides encryption for you. You can hit a checkbox and away you go. But a cookie in your browser can allow access and decryption of that data. So it's really kind of a failed implementation. I still see some people using client-side encryption. But that's really, really hard to manage. I mean, that means you're controlling the keys, you're issuing, revoking the keys, renewing and rotating the keys. You've got to put them out on your applications. You have to figure out how your application is going to get that key securely to decrypt data without embedding it in your code, right? You know, there's a huge amount of there's a huge mountain to move to make that work, and that's why a lot of people go to server side. So both methods really have some key holes in the implementation of how they're done. I mean, the algorithms are good. The encryption keys are good. You know, no one's brute forcing AES-256. It's just not going to happen, especially when, you know, there's flaws in the implementation that make it so much easier. Why would you do that? So I think Microshard technology finally gives you a second control that you can use to control back. I mean, honestly, it can replace encryption too, but and still be very secure. But it can also augment your encryption and really ensure that that the data is not only compliant but is actually also secure. And that's really what Microshard technology helps with there. But this reduction of the attack surface, what it does is it allows you to focus, you know, on the application and the users themselves. So by closing out that backend access and really securing the data from backend access, it means that any attacks are still going to continue coming at your front end, and so you still need to keep those controls in place. But since you have a smaller attack surface, you can really use your security budget and your security resources and focus on that smaller attack surface in a much more effective way. But definitely you should be using tools like MFA and CASB and RBAC and UEPA and stuff on your front-end applications to protect the sensitive data there.
Great. So what I'm hearing, Zach, is from the application layer perspective, when you're using microsharding, not much has changed. I still need to worry about the same things. These are some ideas of things I can use to worry about those. But the advantage is, and I consider the application layer to be the front door to the data, it lets me allocate time and resources to this layer and not have to spend so much time on the concerns about people coming in through the back door at the storage locations and getting the information directly. I'm using backdoor loosely here, not like an incorrectly programmed backdoor, but an administrative backdoor is normally there when you're not using microsharding.
Yeah, that's absolutely correct. If your security team is pulled, in 100 different directions, no one has the resources to just keep hiring more and more and more people, right? We have to do a lot more with a lot less. And so by reducing that attack surface and it allows you to be more focused, more targeted in what your security controls are. And I think overall be more effective in them, both from a budget and resources standpoint.
Yeah, and because it's reducing the scope of what is going to fall under regulatory aspects for sensitive data, since there's no sensitive data in any single location, and the scope of IT audits, it would seem that using microsharding gives you the opportunity to actually recoup some costs and be able to have more that you can allocate for this portion of the equation.
Yes, that's absolutely true. Definitely your, compliance and auditing, you can use those resources elsewhere because you still have to do compliance and auditing. And actually, I'm going to touch on that later. It's not like it goes away, but it certainly gets reduced from the data at rest standpoint. And so it allows you to be more effective where you need it.
Let's kind of move on. We've talked a little bit about some of these implications, and I think it would be good, Zach, if you could summarize them in terms of the implications of using microsharding, and what are those reduced and remaining risks that are there?
Exactly. We've definitely touched on a lot of this, and we've talked a lot about reduced risk. And there's also some remaining risks as well. There's no one solution that's going to cover every single scenario. So let's talk about that. So one is your data sensitivity is reduced, right? So where your data is at rest in your storage areas, they don't contain sensitive information. They don't contain complete data. So the sensitivity has definitely been reduced on that. You've also added privacy to that because, cloud admins, privileged accounts, cloud providers, third parties can no longer actually see the underlying data with back-end access. And again, like you just pointed out a few minutes ago, this definitely reduces the scope for compliance and audits and allows you to focus on other areas.
So for instance, if I were a company worrying, and I was located in Europe and was worried about GDPR compliance, and I want to use one of the big cloud providers, which are all US companies, right. You can see there could be some concerns there. This helps to significantly reduce that risk and not have to worry about that being considered sensitive data by something like GDPR.
Yeah, absolutely. And I would think, especially for anyone under GDPR, that would be a huge boon for them. So next we have the reduced attack surface. So if your data is actually breached or leaked or somehow exfiltrated, it doesn't result in an actual breach of sensitive information, which means no headlines, no regulatory stuff. But there's still some risk there. If an attacker does have access to your cloud platform, they could delete your data they could corrupt your data. So there's still, a chance of, say, a DOS attack by deleting your data. So just having good backup and redundancy, programs in place would help you mitigate that. And then the last thing is remaining risks, really, and that's access to sensitive information. The applications and the users themselves still have access to sensitive information. They need to do their jobs, right? So you still have to put in, a full security stack there. You can be very focused and targeted on what you do, since you're not worried about, sort of platform or backend access. And of course, all that stuff is still in scope for compliance and auditing. You still have to, ensure that the actual legitimate users of the application are still compliant, as well as the application.
Great. That I think this summary really helps. So now that we kind of understand how to securely implement microsharding and understanding what these implications are, I think it would be useful to summarize the types of questions IT auditors might ask and what answers you might be looking for.
Yeah, good. So I do have a bonus slide for auditors. So yeah, some of the questions that an auditor would want to ask for Microshard deployment is, some of the important things we've talked about from the top of this, but how many stores locations are in use? And you're really going to want to see a number, somewhere between 4 and 10. And whether it's single cloud or multi-cloud, do any administrators have access to all the storage locations? You'd really like that separation of duties, which would make any sort of targeted, like spear phishing attack or targeted attack to your admins that much harder to do.
So the desired answer is no admin having access to all the locations.
Precisely. You'll also want to know the shard size being used for the microshards themselves. If the answer is 4 bytes, you can probably stop there. If the answer is anything more than 4 bytes, then you're going to want to drill down into that a little more and find out exactly what kind of data is being stored and if that shard size is sufficient to desensitize that data. It's, this is one of the pillars of Microshard technology. The next thing is, you'll want to know what devices have network access to the Microshard engine. Obviously, it should be very limited, so you want to check, firewall rules or ACLs or whatever to protect that. This is something we touched on earlier. Do admins use the same credentials for the Microshard engine as for cloud access? And in an ideal world, they are totally different credentials. But depending on your scenario, maybe you don't have a good secondary user directory that's integrated into all your security tools and monitoring and MFA and things like that, in which case they probably should be in the same one. So,
but obviously, if they are the same, you are increasing the amount of risk you're accepting, correct?
Certainly. The more privileged an account you get, the more damage can be done, obviously.
Yeah, I mean, it's kind of security 101. You want to check how concentrated privileges are for individual admins. Exactly.
The next one is where are the pointer database and host map files stored and how are they backed up? So they should only be on the Microshard engine itself, except for their backups, and their backups should be definitely secured, right? And in case of disaster recovery, you need to make sure those they have offsite backups as well for any type of restore thing. But those are the key pieces of data you need to reassemble files. So they need to be treated as securely as a private key or anything like that.
So I think you said earlier, one of the things you want to get in, as part of this answer was that the host map file be stored offline.
Absolutely.
The backup, I should say, for the host map file should be stored offline.
Correct, 100%.
Just a little bit more about that. If for any reason I lost the pointer database and host map file and I had to go back to the backup, walk me through kind of how that would work if the host map file is offline?
Yeah, so that's really all the information you need for a Microshard engine to work. So you can spin up, a brand new node or cluster and just initialize it with the pointer database and the host map file. And that's really all you need to restore service. That has all the information you need to locate and reassemble files. Then the last thing is, what controls do you have on the user and application access? And this is sort of irrelevant to the Microshard technology itself, but this is where you're going to be spending your time because this is still the attack surface that remains afterwards, and you should be taking very good care of that, in any case already. But an auditor is probably going to spend their time, a lot of time here on the application layer, because that's where they'll need to focus.
Great, thanks, Zach. And I think we do have a paper as well that people can download. I think if you, that will go through this and how to implement. It's a secure implementation and auditing guide that would be helpful for individuals to kind of summarize these types of things. I've really enjoyed the conversation. I learned a lot. Number one, I learned that I can reduce that data sensitivity surface from, terabytes, petabytes down to, gigabytes or even megabytes. That's a huge reduction and really seems to be a big cost saver. The other aha that I saw going through this is that because the attack surface is significantly reduced, I can spend less of my time worrying about people coming through the back door. In other words, storage location admin access and getting access to data and those types of breaches. And I can spend more of my time worrying about the front door, which you're always going to have to worry about, which is the applications and the users have access to those applications. And it looked like the properly securing and auditing the Microshard engine was straightforward, and keeping it backed up and be able to recover looks straightforward as well. So this has been very helpful to me to be able to learn more about this and to better understand what the implications are from a security and audit perspective. And I hope it's been helpful to you as well. Zach, thank you very much and appreciate you walking us through this. Very, very.
Yeah, thank you, Rob.
Thank you.
Appreciate it. And thanks everyone for joining.
Think about all the sensitive data your business is storing. In the event of a data breach by external attack or internal human error, this data can be exposed. What damage could it do to your business? ShardSecure provides an innovative data security solution. Microshard technology that mitigates data breach risk, ensures data privacy, and improves cloud performance. ShardSecure takes data and breaks it down to the byte level to eliminate its value. Data flows from your front-end applications and services to the ShardSecure engine, where we compress, then shred it into tiny microshards. We add poison data before mixing the microshards into multiple containers that do not have file names, extensions, or location information. The new Microshard containers are streamed to your cloud and on-premises storage locations. Your data can be reassembled and recalled to you at any time. But should any of these cloud locations suffer a security breach, only incomplete and unreadable data is exposed. ShardSecure's Microshard technology is an innovative data security solution that eliminates data sensitivity to ensure total privacy for data at rest and in motion, keeping your business protected. Find out more at ShardSecure.com.